Hi everyone, this is your NJ and you're watching GetWays solution. In today's video, I will solve a Leetcode question again. So without any further delay, let's get started. So question is car fleet, and detail of questions are like this. There are n car going in the same direction. So let's capture the detail. N car going in the same direction along one lane road. So first detail is this. Okay, so I'll write here n car going in, n cars going in the same direction along one lane road, and the destination is target miles away. So we got this, and you are given two integer array position and speed. So we have two integer array position and speed, both of the length n, and we have n car, which means we have n car. For that we have given n position and n speed, and is the position of ith car speed of I, and is the position of ith car in miles speed. So we have given position and speed, and whatever, like suppose we have here I equal to 0, here position is 10 and speed is 2 for the car at 0th index n equal to 0. So that's it, and we have a car can never pass another car ahead of it. Okay, so a car can never pass a car ahead of it, means the car which is behind will always be behind, or what, but it can catch up to it and drive bumper by bumper at the same speed. So suppose we have a car which is faster car which is behind a car which is going slow. So once a faster car reach to the slower car, so now they will drive with the same speed till they reach the target. Don't worry if you didn't understand, I will draw a diagram, you will get each and everything crystal clear. So the faster car will slow down to match the slower car speed. The distance between these two cars is ignored. So a car fleet is some non-empty set of car driving at same position and same speed. Note that single car is also a car fleet. Suppose we have a car and which is so slow, so that it didn't reach the target. It will reach the target when all the car reached. So that single car will considered as one fleet. So that is the thing. If a car catches up to a car fleet right at the destination point, it will still be considered. Suppose some car X which is behind, it will take 1 second to reach the destination, and some car Y which is far, which is ahead of that X car, and that also take 1 second to reach the destination. So at destination they will be together, so that will also be considered as one fleet. Return the number of car fleet that will be arrive at the destination. So we have to return number of car fleet that will arrive at the destination. So I will copy this input, and we will try through this example. We will try to understand what is the question. So here we have input target as 12, so I will draw the line. Okay, so let's understand we have position and speed. So I'll draw a target. So here it is initial point and target is 12. Okay, target is 12. So first position is given as 10. So 10 will lie, let's say, somewhere here. Okay, for 10 speed is given as 2 mile per hour. Okay, speed is 2 mile per hour. I will not write a unit for one only. I will write 2 mile per hour. And now next is 8. Okay, let's say 8 is here, and for 8 we have speed given as 4 mile per hour, and for 0 we have speed is given as 1 mile per hour. Okay, for 0 1 mile per hour. For 5 speed is given as, suppose here somewhere here is 5. So for 5, position 5, speed is given as 1 mile per hour, again 1 mile per hour. For position 3, suppose somewhere here we have 3. For position 3 we have 3 mile per hour. So all of these are speed. So with this speed, can we get something like this is the position 12, we are at 10. So we can say that we have extra, when we are at 10, we have extra 2 mile to cover, because 12 minus 10 it is 2, and speed is 2 mile per hour. So with this speed, can we conclude anything like we are going, this one is the slower car and this one is the faster car? Will they, are we sure, will they overtake each other? Will they overlap each other so that the faster car will slow down and go together? We don't know that exactly, because we can't know, we don't know, like suppose we are at 10, and here to reach 12 we need some time, suppose 1 second, and for this car it might take 2 seconds. So in 1 second it already reached the target, though it was slower, but it reached the target. So with speed we can't tell anything, and we can see here we need time to judge, like if these two car will if these two car will overtake each other and go with the same speed or not. For that we need, from this diagram we can clearly say that we need speed. So let's draw another timeline where we'll have position and speed. Okay, So everybody know that what is the formula of, here we have position and speed. Now I will draw with the respect of time. So what is the formula for time? It will be distance by speed, right? So distance by speed, and distance will be target minus position will be distance, and distance by speed will have this. So we have at 0th position, target is our 12th position, and here we have 10th position, and here we have 8th position, and here we have 5th position, and here we have 3 position. So now let's say we are at 10th position. 10th position distance is what? Distance is 12 minus 10, it is 2, right? 2 by, and what is the speed? We can see at the top, speed is 2 by 2. So time it will take 1 second, just 1 second to reach 12. And we have, when we are at 8, so how much distance remaining? Distance remaining will be 12 minus 8, which will be 4, right? And how much time it will take? And the speed is 4. How much is the speed? Speed is 4. 4 by 4. It will also take 1 second. 1 second. Okay, means both will reach to the target simultaneously at 1 second. So when they reach at the target, at that time both the car will drive bumper by bumper. And we have to consider this. If we read our problem statement, there they have said about this case. So this is also 1 second. Now we'll go ahead with the next one. So here distance is what? 12 minus 5, it is 7. So and speed is what? It is 1. So it will take 7 seconds from here. Now we'll go at position 3. Position 3, if we see, we have 12 minus 3. What is that? 12 minus 3, it is 9. And what is the speed? 9 by 3. So 9 by 3 is 3, right? So at position 0, we have 12 minus 0. So distance is 12 and speed is 1. So it will take 12 seconds from here. So if we see by diagram, we can say that 1 and 1 will overlap at 12. So we can consider them as a one fleet. Okay, 1 and 1 is one fleet. And when you see here 7 is the car, it will take 7 seconds to reach 12, and it will take 3 seconds. The car behind it will take 3 seconds. So 3 seconds, this car is taking 3 seconds, and this car is taking 7 seconds. So what will happen? This car is taking 3 seconds, means of course this car is going to collide with this. So collide with this, and they will go with the same speed. So this one also, the car which is at position 3 will also take 7 seconds, and these two will form one fleet. So we got right now we have two fleets. Now this car will take 12 seconds, but this car will reach target in 7 seconds. This one is in 1 second. So will this 12 collide with anyone? No. So it will form just one fleet. So we can say that right now we have three fleets. Okay. So by looking into the picture, we can say that. But how will, using data structure, how will solve this? How we can conclude same thing, that we have three fleets. So right now, if you looked here, so we have done one thing, like all these position are in sorted order. If you see, like we have, first we have 0th position, whatever we looked from the behind. So first we have looked into the 10th position, and after that we looked into the 8th position, after that 5th position, after that 3rd position. So we got something like we need a pair of, and we want to calculate our time also. So with that we can conclude that our position and speed both are important, and we want this whatever value we got, we want pair of it, and we want the pair to be sorted. Okay, so we want pair to be sorted either in ascending or descending order. If you sort in ascending order, okay, so you have to go backward you have to go backward in the list, and check. If you sort it in descending order, you have to go simply from the first element to the last element and check. And how will check? We have in diagram, by visually we have checked from 10 to 0 and found out the fleets. But how will check? Using data structure. Right now, till now, we figured out that how we will draw this, how we will represent this diagram. We will represent this diagram by forming a pair of position and speed, and we will sort it in order to get it in a sorted form. So we figured out that. Now the next thing to figure out is how to figure out the number of fleets. So to figure out that, what we gonna use, we will have some kind of, we need some kind of track of previous time. If previous time is lesser than, if previous time is lesser than uh, if previous time is lesser than our current time, or you can say that if current time is greater than, anything is fine. If current time is greater than the previous time, which means that this is the car, this car 7, the car which is going to reach here at 12 at 7 second, is not going to meet this car, because by the time it will reach here, this car is the slower car and this car is the faster car. So with this we can conclude that if current time is greater than, if current time is greater than the previous time, the most recent previous time, then we can say that we have one more fleet, but if in case current time is lesser than the previous time, which is here, so in that case we don't have a fleet, and previous time will change, we will not consider previous time as 3 for next 12, when we are at 12, when we are at position 0. Why? Because this will change to the same speed which a car at position 5 have. So I hope you get this point. This is very crucial, very important. So now we are at position 0, again we have greater time, so means we have one more fleet. So we kind of we want to have a previous top element, so for that we can use stack, although you can use other data structure also, but stack seems to be good candidate, because we want to access the top element always, so in that, how stack will be implemented here. So when we are at 10th position, do we have anything in stack? No. If stack is empty, we'll just push the time at position 10. And how we'll calculate the time? Distance by speed. Okay, so now when we are at position 8, so we'll check, like if position 8 we have this time, we'll calculate this time. So if current time is greater than previous time, no, it is not. So we are not going to push anything, in stack. Now again, when we are at 7, we will check. So how we'll get previous time? Always we'll pick the stack, top of the stack, whatever we have, that will be the previous time. So at position 5, we'll check, is 7 greater than 1? Yes, it is. So we have one more fleet. So now at position 3, we'll check, is 3 greater than 7? No, no, 3 is not greater than 7. So we didn't do anything with the stack. To the stack. So which means that 3 will collide with the car which is at position 5 at some point of time, and they will go with the same speed, and time taken to reach target for both of them, 5 and 3, will be 7 seconds. Hopefully you get it. So now we will check at position 0, 12. Is 12 greater than 7? Yes, it is. Indeed, yes, it is. We will push 12 to the stack, and by now we have iterated everything. So what we will do, we will return the size of a stack. That is the number of fleet we have. Hopefully you understood the stack solution. Now let's jump in the code. Let's jump and let's start coding. So I will switch to code, and yes. So first and most important thing, here I will declare, for my convenience I'm declaring an int n equal to position dot length, just to have like this, and I will iterate through n instead of writing position dot length. And after that I will declare one list of integer to keep hold of both position and speed at one place, like kind of creating set of out of it. So let's say this is list, and say new array list, and I will iterate through position and speed. Point I equals to 0, I less than n, and I plus plus. And with that, what we gonna do, we'll create new list here, list of integer, where I will hold all the position and speed combination. So actually it will contain only 2 elements. You can use array also, that is also fine. Let's call it as list, or al array list, new array list. And in this array list I will add position of I, and al dot add. The first element will be position of I, next element will be speed of I, right? So we have now position and speed in our array list, and now we will add this array list to our main list. List dot add new array list, and we'll pass al here. So now we have this all combinations of, like we will have 10, 2, 8, 4, 0, 1, like that. So yeah, we got it hopefully. So now we'll sort this list. How will do sorting? List dot sort, and here you can use anonymous comparator class, or you can use lambda expression. So I'll use lambda expression, comparator dot comparing int, and in that I'll pass the lambda expression, and it goes like this. Here we have to pass the parameter. This is the format of lambda expression. let's say list of integer, and I will call it as say L1, and I have to pass this sign and then statement, and what I will, on what parameter I want to sort the position. Position will be the first one. So L1 dot get 0. So here sorting, here comparator. So we have to reverse it because I don't want to go and look from the behind. So I want it in a reverse order so that I will get the 10th position first. After that, in case of this example, I will get the 10th position time first, then 8th position, then onward. So like that, because of that I am going to reverse it. Okay, reversed. For reverse we can use reversed keyword, so this will be reversed. So this is the complete sorting using lambda expression. You can write anonymous class also, that is also fine, by overriding the comparable method. Now I will declare stack, and that will be the stack of double, because time can exceed, like when we do a position by speed, we might get a certain time which has a value in double, because all of them are not going to be end. So that is the case, we have to use double here, otherwise we'll have some trouble. So new stack, and what we're gonna do, iterate through the list. So let's say list of integer, and let's call it as C, or you can call it as anything. It is going to return us the position and speed. C has that position and speed. It is a list which has position and speed basically. So list, I'm calling it a C, whatever you want to call. You can call as a pair or whatever. P is even good name. Let's say P here only. Okay. So now we'll check if stack is empty. Before doing that, we will just calculate current time, double, let's say current time, current t, I am representing it as current t. So current time will be p dot, it will be target minus, right? We have to calculate distance. Distance will be target minus, first element is the position, target minus p dot get 0, and we have to convert everything in double. So it's double, target minus p dot get 0 by p dot get 1. I'll close this inside a bracket, and that's it. This is how, this is nothing, this is distance by speed, because on the first position we have stored position, and in second position we have stored speed. So hopefully you got it. And now I'll check if stack is empty, and how we represent stack. st dot is empty. If it is not empty, then do something. If it is empty, means we have our first, we are at our first position from backward, means in the nearest position, we are at the nearest position from the target. So at that time we want to have the anyhow, like we will not compare anything, we'll just push the time there. Else if stack is empty, we'll push the time, stack dot push current time. If it is not empty, in that case we will check condition if current time is greater than. So if you look into our example, if current time is greater than, means at position or at previous position, we are coming from backward. That thing you have to keep in mind. And if at previous position we have, value, which is smaller, means the car which is at behind position, and the car which is behind is slower. So and the car which is ahead is faster. So and the car which is ahead will take less time to reach, means it will reach the target. There is no increase in fleet, so we don't have to consider that. So we have to, if current time is greater than previous time, then only we have to consider it as a fleet. So how we'll get the previous time? So previous time will be stack dot peak. In that case, we're gonna push stack dot push current time. That's it. That is the code. Now we have to return stack dot size. It will return the number of fleets. Hopefully you understand everything. It's quite easy once you get once you know things. So let's run it and see do we have any error. If stack dot is empty, why? Every time I forgot something. Okay, it got accepted. Yeah, all case passed. I will try to submit now. So this is the approach we should follow, like generally we should follow. Now I'll tell you the another approach, so which is good, and you should consider that also. Suppose now we have this position, this both this position and speed are given, and now we have we will take what will be that position. Can you guess, like this position, in what range it will lie? It will always lie in the range of 0 to the target, because position will always lie in this range only. We When we see here the target is 12, so is it sensible, like if someone give us the position as 14? No, because when you are behind, then only you can reach the target. So that one thing you need to observe. So with this, by keeping this in mind, what we'll do, so what we can do here is like we go and whatever position we are getting. So suppose here we have position 10, we see position 10 here. Okay, so we'll go here, and at position 10 we will create an array of size 12. Okay, array of size 12, and in that, at position 10 we will store the time it will take, and similarly at position 8 we will store the time it will take, and similarly at position 0 we will store the time it will take, at position 5 we will store the time it will take. So how it is going to help us? So if we I will minimize it and put it to some side. So how it is going to help us, let's see. So suppose we are at position 10, I will create an array of size 12. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here we go. I know this is messy, yeah. So suppose we found some time at 10. So time at 10 we stored. So time at 10 will be what? 12 minus 10, 2 by the speed. So 2. It will be 1 second. Now we found that time at 8, it is also 1 second. We found that time at 8, 1 second. And now we found that time at 5, it is 7 second. Now we find that time at 3, it is 3 second. Now we find the time at 0, it is 12 second. So now what we gonna do? We will go backward. So we need 11 only. So we will go backward. Target minus 1. From target minus 1 to 0 we'll go, and we'll see that if we have current time greater than previous time. So same logic. If we have current time greater than previous time, current time will be what? Here we are at 1. Is 1 is greater than 1? No. So we have like we will have one fleet only. We will not increase the fleet. When we get first element, we will count it as one fleet, and when we'll have current time greater than previous time, so in that case we're gonna count as one fleet. So here if we see, we'll go ahead here. What is the value? 0. Is 0 greater than 1? No. Is again 0 greater than 1? No. Is 7 greater than 1? Yes, we got one more fleet, it's 2. So similarly we go, is 0 greater than 7? No. Is 3 greater than 7? No. So similarly, when we come at 12, is 12 greater than 7? Yes. And that means we have one more fleet. So main thing is to understand this array. So without using stack also we can do this question. So let's see how we can do it. Okay, in code how we can do it. Okay, what the heck? So let's erase this, reset, and let's declare a time array, as we say, and its size will be equal to target. So double array, let's call it as time, and new double of size target. And in order to have number of fleets, to have track of how many fleets we have, we'll initialize one int. Let's call it as fleet, or int fleet, and initialize it with 0. And first thing what we'll do, we'll for int I equal to 0, I less than position dot length, and I plus plus. So here what I'm going to write, just just concentrate on this. So what I will do here, I will say time of position of I. So whatever array I have shown you in a figure, in a diagram, same thing I'm going to do. So at position 10, I'm going to store the time, not at the position 0, 1, 2, 3, like that. So hopefully you got this. This is the most important part of this question. So, and what we gonna do, we'll calculate the time and store double, and for calculating time, distance by speed. And how we'll get the distance? It will be target. Let's write in bracket target minus position of I divided by speed of I. And now in our time array, we have all the element at position at position. So we have time for all the element at position wise. Okay, so now we'll iterate for int I equal to target minus 1, and I should be greater than equal to 0, I minus minus, and that's it. Now in this, what I'm going to do here is get the current time. And how I'll get the current time? Time of I. It will be either 0 or at the position mentioned will be the value which we have inserted. So now we'll check if current time, if current, let's say it as current time instead of saying it as current, if current time is greater than previous, and we need previous also. How will get the previous? Let's say previous, initialize one previous, int previous, time is double, so double previous equal to 0 if current greater than previous. So in that case, we're gonna count it as one fleet, and when we get a fleet, we used to we will update the previous also. Previous equal to current time and fleet plus plus, and at the end we will return the fleet. So let's run it. Yeah, all test case pass, submit. So hopefully you understand second solution also. Thank you. Bye bye.